Okay, notes 1, linear inequalities. So in these notes, we're going to talk about several concepts, and the first concept is how to graph linear inequalities. It says a linear inequality in one variable x is any inequality that can be written in the following form. So we have ax plus b less than c, ax plus b less than or equal to c, and so on and so forth. Okay, notice that all of these are the same. They're just representing some sort of function that are either less than or equal to, greater than, or greater than or equal to some other number. Okay. So before we continue these, we have to know what it means to be less than or greater than, and how we would use these symbols to graph it on the number line. So if we have a open circle, that's equivalent of having parentheses. Okay, parentheses tell us that values are not included. This is the same as saying less than or greater than. Okay, same with the other ones. If we have a closed dot, that's the same as saying brackets, which means we include the value, and that's the same as using the symbols less than or equal to or greater than or equal to. So looking at the first example here, this says x is greater than -1. So I'm going to plot -1. This is greater than and not equal to, so I'm going to do an open dot. And all numbers bigger than -1 are going to go to the right. Next one, we have x is greater than or equal to 7/3. So I write 7/3. Greater than or equal to is going to be a solid dot. And then again, I'm going to point my arrow to the right. This one is 3 is greater than x. Well, this is not proper notation. We would have to first write it in proper notation, and it would be x less than 3. Notice that I didn't change the inequality. I'm still having this point of the inequality point to the x. Look, it's still pointing to the x. I just wrote it in proper notation. So I'm going to put a 3, an open dot, and this says x is less than 3, so it's going to go to the left. Okay, on the next one, I'm going to put 0. This says x is less than 0. Another open dot because it's not included, and then I'm going to point my arrow to the left. Then I have x is greater than or equal to -5/4, so here's my -5/4. Greater than or equal to tells me it's a solid dot, and I'm going to go to the right. And then lastly, I need to write this in proper notation, so this becomes x is less than or equal to 5. So I write 5 with a closed dot. Less than or equal means everything to the left. Okay, now we're going to look at compound inequalities. So compound inequalities involve more than one inequality. So notice in here we have two numbers. We have -4.1 and -1.7, and we have x in between those values. Well, the inequality that is next to each of the numbers is going to determine if we're going to put a closed or open dot. So above -4.1, we're going to put an open dot because that is just less than. And then above -1.7, we're going to put a closed dot because that's less than or equal to. And since x is between those values, I'm just going to connect the lines between. Same with this one, I have 0 and 8.5. Both of them are less than and equal to, so I'm going to do a closed dot. And then I'm going to connect them in between. Okay, concept 2 is the difference between set builder notation and interval notation. So in this example, I am using the inequality x is greater than or equal to 2. So for set builder notation, it is always going to look like this form. Okay, so notice it's like the curly brackets, and then it has x, and x is just representing the variable, such that, and then notice how this entire thing just went right here, x greater than or equal to 2. So when we do set builder notation, we're just rewriting the inequality in there inside of those curly brackets with the x and the bar representing such that. For interval notation, notice how we have this graph here. Okay, they did a little bracket on the 2, but really this would be a closed dot and then an arrow to the right. Well, that closed dot is representing the bracket. That's why they wrote the bracket there. And the arrow to the right is telling us that we're going to all the numbers, okay, bigger than 2, on and on and on and on, which means we're going towards infinity. So when we write our interval notation, that's how we did bracket 2, comma, infinity, parenthesis. Very important. Anytime we see an infinity sign, whether that's negative or positive infinity, the notation around it is always going to be a parenthesis because we cannot stop infinity. Infinity is a number that goes on forever. Okay, so more of kind of the same thing that we talked about and some more examples showing how we would write the interval notations based on how the graphs looked. Okay, so now let's look at some examples. So the first one says x is less than negative 3. So I'm going to graph it. Okay, less than, so that's an open circle, arrow to the left. Set builder notation, I do curly brackets, x such that x is less than negative 3. Notice that I just moved whatever my inequality was inside of the curly brackets, and that is my set builder notation. For here, this is saying x is all numbers smaller than negative 3, which means I'm going to approach negative infinity and go up to negative 3. But since I have an open circle on the negative 3, I know I'm going to use a parentheses. Okay. The next one, I have negative 1/2. Okay, close dot because it's greater than or equal to, and then arrow to the right. So this would be x such that x is greater than or equal to negative 1/2. And then greater than negative 1/2 means we're going to include negative 1/2 and go up to infinity. Okay. The next one, we have something that's between. So we have negative 2 and we have 4. On the negative 2 is less than or equal to, so that's a closed dot. On 4, it's less than, so that's an open dot. And then I just connect them in between. Okay, which means I have x such that negative 2 is less than or equal to x less than 4. Again, I'm always writing whatever is in my example into my set builder. Okay, and then based on what I drew, either a closed dot or an open dot determines if I use a bracket or parentheses. So this is going to be bracket negative 2, 4, parentheses. Okay, my next one is x is greater than or equal to negative 2, so here's negative 2. Greater than or equal to means I'm going to have a closed dot, and this is going to be pointing to the right. Set builder means I am going to do x such that x is greater than or equal to negative 2. And then since I have a closed dot there, this is bracket negative 2 going towards infinity. Next, I have x is less than 3/2. So this is going to be open circle, less than is going to go to the left. So this is going to be x such that x is less than 3/2. Okay. Less than means I'm approaching negative infinity and I'm going up to 3/2, but I'm not including it because of that open circle. And then lastly, I have negative 3 is less than x, less than or equal to 1. I'm going to do an open circle on negative 3 and a closed circle on 1. And since x is between those two values, I'm connecting those 2 points. Which means for set builder notation, I have x such that negative 3 is less than x, less than or equal to 1. Okay, exactly what I have here. And then I have negative 3 with the parentheses and then 1 with the bracket. Okay, next concept is adding or subtracting properties of inequalities. So all this says is that if we were adding or subtracting values to either side of the inequality, that the inequality does not change. Okay. For example, notice how I have negative 2x plus 5 less than negative 3x plus 6. Here, I don't have my variables all on one side. I don't have it solved for me, so I have to solve it first. And so for here, I'm going to make sure my x's are on this side and my numbers are on that side. Okay? So in order to move all my x's to the left, I'm going to add 3x over. This becomes x. I bring down the plus 5. The negative 3x and the positive 3x cancel, and I bring down the 6. Okay, and then I'm going to also bring down my inequality. Then I want to move my numbers over to the other side. So I'm going to subtract 5, and I get x is less than 1. Okay, because I bring down the x, the 5's cancel out, and 6 minus 5 is 1. Okay. Well, I can take that and now graph it off to the side. So if I have 1, I know it's going to be an open circle above 1, and x is less than means everything to the left. I can also check this to see if I did it correctly. So in order to check, I have to think, okay, if x is less than 1, I need to choose an x value that is actually less than 1. So I'm going to choose x equals 0. And then I'm going to plug in x equals 0 into my original equation. So negative 2x plus 5 less than negative 3x plus 6. Plug in 0, so negative 2 times 0 plus 5 less than negative 3 times 0 plus 6. So everything with that 0 is multiplying, so it cancels out to 0, and I'm left with 5 is less than 6, which is a true statement. I can then take this, since I have verified that I did it correctly, and put it into set builder and interval notation. Set builder, this would be x such that x is less than 1. And interval notation, since it's going towards negative infinity, is going to be negative infinity to 1 with the parenthesis because it's not including it. Okay. Next example, I'm going to do the same thing, move my x's over to one side and my numbers over to the other. Okay, so moving my x over, that's subtracting x. Okay, 2x minus x is just x. Bring down minus 5. My x's cancel out. Bring down negative 11 and also bring down my inequality. Then I'm going to add 5 to the other side, and this is going to give me x is less than negative 6. Because I bring down the x, my 5's cancel, and then negative 11 plus 5 is negative 6. Okay, so we're going to go ahead and graph it and then check. So if x is less than negative 6, I have negative 6. I still have an open circle, and then I have all values to the left. Which means in order to check this, I need to choose x that is x less than negative 6. And that x could be negative 7. It could also be negative 10, negative 100, any value that satisfies that condition. So then I plug it into my original equation, 2x minus 5 less than x minus 11. So I have 2 times negative 7 minus 5 less than negative 7 minus 11. This is negative 14 minus 5 less than negative 18. So negative 19 is less than negative 18, which is a true statement. So that means I did my math correctly. Set builder notation means I'm going to do x such that x is less than negative 6. And interval notation, since it's going to be less than negative 6, is going to approach negative infinity. So this is negative infinity to negative 6 with the parentheses because it's not being included. Okay, the next concept here is multiplying or dividing inequalities. The big thing here is this right here. Okay. If both sides of an inequality are multiplied or divided by a negative number, the inequality sign must flip. Okay, so if we multiply or divide by a negative number, the inequality will flip. If we don't, then the inequality stays the same. Okay, so for here, we need to move all of the numbers over and leave the x by itself. So in order to do that, I'm going to first add 3 to both sides. So I have negative 5x is less than or equal to 15. Then divide by negative 5, and I get x is greater than or equal to negative 3. Okay, I divided by a negative, which means that this inequality is going to flip. Okay, so that's my answer. X is greater than or equal to negative 3. Next example, I'm going to subtract 2. I get negative 5x is greater than 20. Divide by negative 5, and I get x is less than negative 4. Again, I divided by a negative, so my inequality flipped. Okay, now I have something a little bit more complicated here because now I have the parentheses, which means before I can start moving everything over to other sides, I need to make sure that I simplify as much as I can first. And the first thing I'm going to do is I'm going to get rid of these parentheses by distributing the negative 2 and distributing the negative 3. All that means is I'm going to multiply inside the parentheses by negative 2 and multiply inside the parentheses by negative 3. So I have 12 minus 2x, because negative 2 times x, minus 6, because negative 2 times 3, is less than negative 6x, because negative 3 times 2x, plus 3, because negative 3 times negative 1, and then bring down the 2x. Now I'm going to combine like terms. 12 minus 6 is 6, so I have negative 2x plus 6 is less than negative 6x plus 2x is negative 4x, and then I bring down the plus 3. Remember that my x's are on this side and my numbers are on this side. Okay, so first I'm going to add the 4x over, and I get 2x plus 6 is less than 3. Then I'm going to subtract 6 to the other side, and I get 2x is less than negative 3. And then divide both sides by 2, I get x is less than negative 3/2, or negative 1.5. Doesn't matter if you leave it in fraction or in decimal. But notice, this entire time, I never divided or multiplied by a negative. That's why my sign stayed the same. Okay, next example, I'm going to do the same thing. I'm going to distribute negative 8 inside the parentheses and then negative 5 inside the parentheses. So I get negative 8 minus 16x plus 32. I multiplied each one by negative 8. Is greater than negative 20x plus 25, bring down minus 21, because I multiplied each term by negative 5. Then I'm going to combine like terms. Negative 8 and 32 is 24, bring down the minus 16x, is greater than, and then 25 minus 21 is 4, so I bring down minus 20x plus 4. I need to move my x's to one side, so plus 20x plus 20x. I get 24 plus 4x is greater than 4. Subtract 24 from both sides, and I get 4x is greater than negative 20. Divide by 4, and I get x is greater than negative 5. Again, notice I never multiplied or divided by a negative, so my sign stayed the same. Okay, now we're moving on to everybody's favorites, and that is fractions. And I'm going to show you how to get rid of these fractions so we don't have to deal with them later. Okay, and in order to do that, the first thing you're going to do is you're going to look at each of these denominators. So we have 4, 6, and 3. Okay, 4, 6, and 3. When you do this, okay, you are going to think of a number that all of them can divide into, okay? So a number that they each can divide into would be 12. So I'm going to take this whole thing, and I'm going to multiply by 12. So what I have here is 12 times negative 1/4. Or I can think of this as 12 over 1. Okay. And then I'm going to multiply. When I multiply 12 over 1 by negative 1 over 4, that's the same as doing 12 divided by negative 4. And that gives me negative 3x. Okay. Then I have 12 divided by 6, which is 2, so plus 2. Bring down my inequality. Okay. Then I am going to do 12 times 2, which is 24. And then 12 over 1 times 2 over 3x, where I'm going to do 12 divided by 3, which is 4, and 4 times 2, which is 8, so plus 8x. Okay, when I do that, I get rid of all the fractions. So now all I have to do is move my numbers to one side and my x's to the other. So I'm going to subtract 8x, and I get a negative 11x plus 2 is less than or equal to 24. Then I'm going to minus 2 over, and I get negative 11x is less than or equal to 22. And then I'm going to divide both sides by negative 11, which means since I'm dividing by a negative, my sign is going to flip. So I'm left with x is greater than or equal to negative 2. Okay, I'm going to do the same thing on this side. So notice that my denominator here is 5 and 2. Okay, a number that both of them can divide into would be 10. So I'm going to multiply this entire thing by 10, which means I have 10 divided by 5, which is 2, so 2x. 10 times 7, which is 70. 10 divided by 2, which is 5x. And then 10 times negative 2, which is negative 20. I'm then going to subtract the 5x over, and I get negative 3x plus 70 is less than or equal to negative 20. Subtract 70 over, and I get negative 3x is less than or equal to negative 90. Divide by negative 3, which means my sign flips. So I get x is greater than or equal to 30. That is my answer. Okay, next concept here is, okay, well, let's say we have the same thing where we need to simplify and get x by itself, but now we're dealing with compound inequalities. Means we have more than one inequality. For these ones, we want to get x by itself in the middle, which means we need to either get rid of these numbers, but make sure we do it to all sides. So I want you to think, okay, you're a parent, you have 2 children. Whatever you give or take from one child, you need to give or take from the other child. So that's what we're going to do. So first I'm going to take 1 from each of my kids. Okay, so I have negative 4 is less than or equal to 2x less than 6. Now I'm going to each of my kids divide by 2. And I get negative 2 less than or equal to x less than 3. That would be my answer because I am left with x by itself in the center. Okay, same with this one. My first step would to give 5 to all my kids. So plus 5 plus 5. So I get 2 is less than or equal to 2x less than 16. Divide everything by 2, and I get 1 is less than or equal to x less than 8. Notice in none of these, I never multiplied or divided by a negative number, which means my signs did not flip for any of them. Next concept is applications. Okay, so what that means is we should be able to read a word problem, an application problem, and decipher what the words, the English phrase is in order to turn it into an inequality. So some examples here, we have less than, which of course is less than, greater than, which is greater than, at most or no more than, that represents less than or equal to, and at least or no less than is greater than or equal to. So let's look at some examples. Okay, one says Joe's annual salary is no more than $40,000. No more than means we're going to use less than or equal to. But I have to identify a variable. So I'm going to say X is equal to salary, which means Joe's salary has to be less than or equal to $40,000, which means he cannot make more than $40,000. 2 says a citizen must be at least 18 years old to vote. So let X equal the age of the citizen, and at least means it has to be greater than or equal to. So this is X greater than or equal to 18. Number 3 says an amusement park ride has a height requirement between 48 and 70 inches. Okay, between means X has to be between those values. So it would be 48 is less than or equal to X, less than or equal to 70, where X is equal to your height. Okay, which means you can be 48 inches tall and you can be 70 inches tall. You can be any number in between, but you can't be smaller than 48 or taller than 70 inches. Okay, number 4 says Bill needs a score of at least 92 on the final exam. So at least 92. So let X equal Bill's score. At least tells us greater than or equal to. So X is greater than or equal to 92. This tells us Bill would be happy if he got something higher than a 92. And he would not be happy if he scored lower than a 92. Okay. Number 5 says fewer than 19 cars. Fewer than is representing less than. Okay, so let X equal cars. So X is less than 19 cars. 6 says the heights H, this one gives us a variable, of women who wear petite clothing are typically between 58 and 63 inches tall. So that means 58 is less than or equal to H, less than or equal to 63. Number 7 says, to earn an A in the math class, Ashley must average at least 90 on all her tests. Suppose she scored a 79, 86, 93, 90, and 95 on her first 5 tests. Determine the minimum score she would need on her 6 tests to get an A. So at least 90. This tells us that 90, whatever the average is, okay, can be greater. But 90 is the minimum value. So in order to calculate average, we add up all the numbers and divide by the total number. So 79 plus 86 plus 93 plus 90 plus 95 plus X. We're going to let X represent her 6 tests. And then we're going to divide this all by 6. So if I was to simplify this, this would be 90 less than or equal to 443 plus X divided by 6. I'm going to get X by itself by multiplying both sides by 6, which means I have 540 is less than or equal to 443 plus X. I subtract 443 from both sides, and I get 97 is less than or equal to X, but in proper notation, that is X greater than or equal to 97, which means Ashley must score at least a 97 on her 6 tests to get a 90 or an A in the class. Okay, last question here. To earn a B in a math class, Simon must average at least an 80 on all his tests. Suppose he scored a 60, a 72, a 98, and 85 on his first 4 tests. Determine the minimum score he needs on his 5th test to get a B. So at least 80. So that's 80 is less than or equal to the sum of all their tests. And we're going to let X be his 5th test. And then we're dividing this all by 5. Simplifying this, this is 80 is less than or equal to 315 plus X over 5. I am going to multiply both sides by 5. So I get 400 is less than or equal to 315 plus x. Subtract 315 from both sides. And I get 85 is less than or equal to x. Proper notation means x is greater than or equal to 85, which means he needs to score at least an 85 on his next test to get a B in the class.